Everyone, today's topic is age word problems. As a reminder, you do not need to write down everything we cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you got it. Just be careful and make sure you don't fast forward so much that you miss out on something important. Let's get started. It's a good idea for you to pause the video and jot down the steps for setting up equations of age problems. Remember that you can always use your steps and examples in your notes to look at as you are practicing these exercises. The first step is to create a variable to represent each unknown value. And then the second step is to create two or more equations that are going to describe each sentence in the problem. And there are some key words you're going to want to keep in mind. For addition, you'll usually see something in the problem that says blank years older than, or in blank years. For subtract, you will probably see phrases like blank years younger than or blank years ago, meaning it happened in the past, so we're subtracting to get there. While for addition, it's in however many years, so we're adding to get to the future. And if the problem says blank times as old as, the times tells you to multiply. Now here's something that's a little different in terms of keywords. So equal. You know, in equations you have the equal sign, but there's actually words that tell you how to get to equal. So when you see the word is or was, it tells you to use an equal sign in your equation. And we'll go over some examples of that. And then once you have your equation set up, you're going to use any method to solve your system of equations. Let's take a look at some examples. In this age word problem, they're telling us that Ishan is 72 years old and William is 4 years old. How many years will it take until Ishan is only 5 times as old as William? So in this problem, they're telling us exactly how old the two people are. Those are not our unknown values. What's unknown is the amount of years it's going to take. So we're going to set up an unknown variable for that. So in how many years, that's our unknown. So let's make y the number of years. We have no idea what that answer is, okay? So then we're going to reread the problem, and we are going to set up an equation for each sentence that we see. They want to know in how many years, so that's in the future, so that means we're going to have to add that to y, because we don't know how many years in the future it will take for Ishan to be 5 times as old as William. And Ishan is 72 years old. So Ishan is 72 right now, and William is 4 years old. We don't know in how many years, so we're going to add that to y. So in blank amount of years, a mysterious amount of years, Ishan will be 72 years old plus y, the number of years that will have passed in addition to right now, and William will be 4 plus y. Again, we don't know what that y is. We don't know how many years we're talking about. And in y years in the future, Ishan is going to be 5 times as old as William. So however old William will be in however many years we're talking about, we're going to be able to take William's age and multiply it by 5. And then that will be equal to it's going to be equal to Ishan's age. Okay, so we're saying Ishan is 72 now. In a mysterious amount of years, which we labeled as y, he will be 72 plus y. And his age will be equal to 5 times the age, 5 times as old as William's age in that mysterious amount of years. So both of them have to add y, the mysterious amount of years in the future. Because it's not like we're saying William is going to stay 4, but then Ishan is going to keep getting older, right? If Ishan gets older by y amount of years, William will also get older by y amount of years. But we're saying in that many years, now William will be 5 times as old as William. Okay, so the adding y puts us into the future. This is future Ishan. And then adding y here puts us in the future for William, future William. We're just saying here now that future William is going to be 5 times, multiplied by 5 to get to Ishan's age, because Ishan will be 5 times as old as William. Okay, so that's how we set that up. And then now that you're here, you're going to use any method to solve. We only have one equation, so we're going to solve it like a normal equation. Sometimes you're going to have more than one equation, and then you'll have to use your system of equation methods. But for most of these age problems, you'll just have one equation. So here I know I have to multiply by my parentheses. So I end up with 72 plus y equals 5 times 4 is 20. 5 times y is 5y. So we end up with 72 plus y equals 20 plus 5y. I can see if there are any like terms to combine on both sides. No over here, no over here. So then I have to start moving my variables and my numbers to the same sides. I'm going to move this smaller y to the larger y side. So these cancel, and I end up with 72 equals 20. This is 5y minus 1y, that'll be 4y. And then I have my y's on one side, I'm going to move this 20 to meet the other side so that I have only y's on the right hand side. 72 minus 20 is, let's see, 52. So then I'm going to divide by 4 on each side. Running out of room there. So y equals to 52 divided by 4. 52 divided by 4 is 1 over here. Bring down the 2. 13. So y equals to 13. So we're saying in 13 years, Ishan will be 5 times as old as William. Well, let's check it. In 13 years, Ishan will be 85, because we just added 13, and William will be 17. So is 17 times 5 equal to 85? Yes, it is. Okay? So that's why we added the y to both of them in the equation, because we're trying to find out in how many years will they be 5 times. Will Ishan be 5 times as old as William? So we have to have the adding of that mystery number in both of them. And then at the end, we're multiplying William's age by 5 to see if it's equal to Ishan's age. So to check it, we're doing the same work as in the equation. So this answer should be 13. In 13 years, Ishan will be 5 times as old. And that is correct. Okay, let's try another problem. In this problem, they say that Kevin is 2 times as old as Gabriella. 12 years ago, Kevin was 6 times as old as Gabriella. How old is Kevin now? Go ahead and pause the video and try this one on your own. Alright, so they want to know how old Kevin is now. We know that Kevin is 2 times as old as Gabriella. 12 years ago, Kevin was 6 times as old as Gabriella. We don't really know how old either one of them is, right? So K is definitely going to be a variable. That's Kevin's age. We don't know how old Kevin is, so we're going to make that into a variable. Anything that's unknown becomes a variable because we got to solve for it. We also don't know how old Gabriella is, so let's make this Gabriella's age. K and G, pretty easy to remember. And then let's start creating equations. So let's take a look at the first sentence. Kevin is 2 times as old as Gabriella. I see an is, which tells me equal, and I see a times, which tells me multiply. So Kevin is 2 times as old as Gabriella. K equals 2G. So Kevin is older. He's 2 times as old as Gabriella. This equation makes sense because I would have to take Gabriella's age and multiply by 2 to equal to Kevin's age, because Kevin is 2 times as old as Gabriella. So you can always double check with just some logic to make sure your equation makes sense. Or you could translate it that way with the keywords. Kevin, K, is equals 2 times as old as Gabriella, G, which we don't know. That's the first sentence. The next sentence says 12 years ago, so the key word is ago, which means it happened already. So it means we're going to subtract later on. So let me put the keywords and operations up there. It's 12 years ago, so that's in the past. We're going to have to subtract. Kevin, that's a K, was equals 6 times as old as Gabriella. Okay, so 12 years ago, Kevin would be K minus 12 because he was 12 years younger than what he is right now. This is their now ages, okay, in the present. So 12 years ago, K minus 12, Kevin was equals 6 times as old as Gabriella. Now here, this one is tricky, okay? This is 12 years ago for both of them. So 12 years ago, it's K minus 12. 12 years ago, it's G minus 12 as well. And then I'm going to put parentheses around here because just like the Ishan and William problem, I need to figure out how old Gabriella was 12 years ago before I multiply by 6, right? She's going to be younger, and then we take that younger age and multiply by 6. So I need to make sure that the subtraction goes in the parentheses to show that we have to do that first. And then since Kevin, we're going back in the past, 12 years ago, to find out his age, we got to do the same thing for Gabriella. We're not turning back time for Kevin, but not for Gabriella. Time doesn't work like that. It has to be fair for both of them. Okay, so whenever you have somebody going back in time or forwards in time, but not the other person, something is probably off. Unless they say 12 years ago, Kevin was 6 times as old as Gabrielle is now. But they didn't say that. They're saying 12 years ago for both of them. Okay? So you end up with 2 equations. And usually this is when people freak out. But remember, double check your sentences and make sure that those equations make sense. And then you can use any method to solve these. You can use, probably don't want to use a graphing method because it's easier when you have y's and x's, but you could change it so that one is x and one is y. But then you have the graphing paper you need to take out and all that. Substitution could work here because we have a variable that's already isolated. K is equal to 2g. So wherever I see k here in the other equation, I could replace it with 2g. So that could work out. And then elimination could work out here. You just have to make sure you have an elimination variable. So I would say usually you would go with substitution or elimination. Here, since I already set it up, let's go with substitution. Instead of k in this equation, I'm going to put 2g right here. Okay, because k is the same as 2g. So instead of k minus 12, I'm going to write 2g minus 12 equals 6 times the quantity of g minus 12. So I've now kind of combined both of my equations together into one by using both the information. And I've eliminated k. In my previous equations, both of them had k and g. So by substituting 2g for k in the second equation, I'm down to just g, and I can solve it normally. I have parentheses, so I'm going to multiply that through. So I end up with 6g minus 6 times 12 is 72. And then I can combine like terms on the same sides, but I don't have any, so I'm going to start moving my smaller g to my larger g side. Cancels. This is negative 12. 6g minus 2g is 4g, and this is minus 72. So I have all my g's on the right-hand side. Now I need to move all my numbers, my constants, to the left-hand side. I'm going to add 72 on this side to cancel out, eliminate that. This is 72 minus 12, pretty much. It's just an opposite order. So I end up with 60. And then this is 60 equals 4g, 4 times g, so the opposite is dividing by 4. 60 divided by 4 will be, bring down the 0, 5. So it's 15. So g equals 15. That's Gabriella's age. Gabriella is 15, okay? But since we have Gabriella's age, we can easily find out Kevin's age. Kevin is 2 times as old as Gabriella. So Kevin has to be 30 because he's 2 times as old. 2 times 15 is 30. And then I can just go through the second equation and make sure that makes sense. So 12 years ago, Kevin would be, let's see, did I do that correctly? Yes. Kevin would be 18. 12 years ago, Kevin was 18. And Gabriella minus 12 would have been 3. So 12 years ago, Kevin was 6 times as old as Gabriella. Can we take Gabriella's age 12 years ago and get Kevin's age 12 years ago? Yes, we can. So that means our answer 15 is correct. Oh no, sorry, not 15. 15 was Gabriella. Whew, safe. Oh, so close. Save myself there. Kevin's age is 30 now. So sometimes the variable that you actually solve for is not the variable that they actually ask for. So you have to read the problem carefully and make sure you're not just putting in whatever like I almost did. Okay, so try those out on your own. As long as you follow those steps and you double check and make sure that the translation of your words into equations is good, then the rest is just the math that you've learned before. Let me know if you have any questions as you work on this, and I'll see you in class.